Good morning students, this is the class for 10th standard science subject in physics. Our first lesson is laws of motion. Okay, in last class we have seen the principle of conservation of linear momentum and rocket propulsion and Newton's law of gravitation. Okay, so to continue that lesson, now we are going to learn about the acceleration due to gravity. Okay, that is denoted by small g. Okay, so first when you throw an object, okay, when you throw on any object upward direction means at that time the velocity that just increases at a particular height. Okay, at a particular height when we can throw on any object means the velocity of the object will increase. Okay, so and after the some time that will falls down due to the gravitational force of the earth. Okay, so due to the gravitational force of the earth, okay, due to the gravitational force of the earth, that object will falls down after a some time. Okay, so at that time the velocity of an object keep changing and it falls down. Okay, the velocity of the objects decreases and comes to the downward direction. Okay, that means falls down. Okay students, this change in velocity due to the force acting on that object. Okay, because of the force the velocity is changed. Okay, so this change in velocity due to the force acting on that object. Okay, so the acceleration of the body is due to the earth gravitational force. Okay, so acceleration of the body earth gravitational force, hence this acceleration is due to the gravitational force of the earth. Okay, so that gravitational force is called as the gravitational force of the earth, and this is otherwise called as the acceleration due to gravity of the earth. Okay, so this is called as one type is gravitational force of the earth and otherwise called as acceleration due to gravity of the earth. Okay, and it's denoted by small g, and it the SI unit of acceleration is already we know. Okay, the SI unit of acceleration is meter second power minus 2. Okay, so here also the SI unit of acceleration due to gravity is meter second power minus 2. Okay, because this is the acceleration. Okay, then the mean value of the acceleration due to gravity, that is the value of g. Okay, that is the value of g is 9.8 meter second power minus 2. This is on the surface of the earth. Okay, so earth surface, okay, surface of the earth, the g has a value of 9.8 meter second power minus 2. Okay, so this value of g is not same. Okay, at all points. Okay, so the value of g is not same. Okay, it can be varied or changed. Okay, on the surface of the earth. So next one is the relation between capital G and small g. Okay, small g refers to the acceleration due to gravity of the earth, and capital G is called as the universal gravitation constant. Okay, in previous classes we have already saw. Okay, so now we are going to see about the relation. Okay, so the relation between small g and capital G. Okay, for that first, when a body is at rest on the surface of the earth. Okay, so the earth surface, one body is at rest. Okay, so let us calculate the magnitude of this force. Okay, so we have to calculate the magnitude of this force means we have to process in two ways. Okay, so first one is what means, let us consider capital M be the, okay, first we have to consider capital M, that be the mass of the earth. Okay, capital M be the mass of the earth and small m be the mass of the object or any body. Okay, so then the entire mass of the earth is concentrated at its center. Okay, so this one is the earth and this one is the object or body. Okay, so the mass of the earth is capital M, mass of the object is small m, and the force acted on these two is capital F. Okay, so what we have they tell means then the entire mass of the earth is concentrated at its center. Okay, so the entire mass of the earth is concentrated as its center means here. Okay, is concentrated as its center. Okay, then the radius of the earth. Okay, radius means the radius of the circle is from the edge to the corner point. Okay, so sorry, from the center point to the edge point or corner point. Okay, that is called as radius. Okay, so the radius of the earth is given by it's denoted as capital R, and the value is 6378 kilometer. Okay, or we have to consider as round of value means, okay, that is approximate value means for our consideration. Okay, we have to approximate value means R is equal to 6400 kilometer. Okay, this is for our convenient. Okay, we have to round off the value. So for the calculation of the force, first we have to consider by using the Newton's law of gravitation. Okay, so by using the Newton's law of gravitation, the force acting on the body is given by, okay, by using the Newton law of gravitation, the force acting on the body or object is given by F is equal to capital G into small m and capital M by R square. Okay, so this equation we have to consider as the first equation. Okay students, here the radius of the object is negligible because the radius of the object or body is very small. Okay, so as it compared with the radius of the earth means this can be deleted or negligible. Okay, so the radius of the object is very small. Okay, so that it can be negligible, okay, as compared with the earth radius. Okay students, now the same force is calculated from the Newton's second law of motion. Okay, the same force is calculated by the Newton's second law of motion. Newton's second law of motion, already we know that Newton's second law of motion is F is equal to m into a. Okay, so F is equal to m into a. Here m is the same, but the acceleration is not the normal acceleration. Okay, because if we take the case of here acceleration due to gravity. Okay, so here a is replaced by g because of the gravity acceleration. Okay, so that we have the Newton's second law of motion as F is equal to m into g. Okay, so this we have to consider as the second equation. Okay, so comparing equation 1 and 2, we get m into g is equal to gmm by r square. Okay, so in both cases, okay, both side, left hand side as well as right hand side, the mm will get cancelled and the remaining terms are g is equal to gm by r squared. Okay, so we have to consider this equation as the third equation. Okay students, so next topic is what means to calculate the mass of the earth. Okay, that is denoted by capital M. Okay, so rearranging the equation 3, what is the equation 3? Equation 3 is g is equal to gm by r squared. Okay, so this is the equation 3. We have to rearrange the equations means easily we can calculate the mass of the earth. Okay, how means gm by r squared is equal to g. We have to calculate the mass of the earth means, so this is considered to be as the left hand side and this is the right hand side. So we have to calculate only the mass of the earth means this g goes the downside of the right hand side. Okay, so that we have m is equal to g r squared by capital G. Okay, so this is the equation 4. If we know the value of, to calculate the mass of the earth means if we know the value of small g, capital G and the radius of the earth means easily we can calculate the mass of the earth. Okay, if we know the value, what is the acceleration due to gravity? Small g is equal to 9.8 meter second power minus 2. Okay, and we know the value of the earth is 6400 kilometer. Okay, so the SI unit is kilometer. Here we have to consider the meter means we have to put instead of a kilo as 10 to the power of 3. Okay, so r square we have to put square and divided by the universal gravitation constant, that is capital G is 6.674 into 10 to the power of minus 11. Okay, so we have to put these values. The mass of the earth will get as 5.972 into 10 to the power of 24 kilogram. Okay, kilo, because the SI unit of mass is kilogram. Okay, so that we have to put kilogram. Okay, so the next one is what means variation of acceleration due to gravity. Okay, so the acceleration gravity is varied from place to place. Okay, so next topic is how will be varied, okay, from place to place. So from the acceleration due to gravity formula, g is inversely proportional to square root of the radius of the earth. Okay, that is g is inversely proportional to 1 by r square. Okay, so from this we can say that g depends on the geometric radius of the earth. Okay, so this g is depends on the geometric radius of the earth. Okay, so the value of g varies from one place to another place. Okay, this is not a constant, okay, fixed one. This is changed or varied from place to place. Okay, so the geometric radius of the earth is maximum at the equatorial region. Okay, we have the two regions, so one is polar region, another one is the equatorial region. Okay, so the geometric radius of the earth is maximum. Okay, so the value of the r is high at the equatorial region. Okay, so at the time the value of g is minimum. Okay, how means, because it's inversely proportional. Okay, directly proportional kadiyadu, inversely proportional. Okay, so that we can tell us the value of r is high means the value of g is low. Okay, so at the equatorial region the geometric radius is high means the value of g is minimum. Okay, and in the case of your polar region this is the opposite. Okay, so the geometric radius is minimum at the polar region and the value of g is maximum. Okay, in the case of polar region. Okay, then we have to see the three cases. Okay, first one is what means, if we move a surface of the earth. Okay, if we move any object or any body from the surface of the earth to a higher altitude means, okay, surface of the earth la irundha higher altitude ku kondu pona appadina the value of g will be decreased. Okay, same if we move from the surface of the earth to the deep below the earth. Okay, that is due to the belong to the sea level. Okay, deep below the earth means the value of g decreases. Okay, the third case is at the center of the earth the acceleration due to gravity is 0. Okay, so there are three cases. One is the center of the earth, another one is the above the earth, and another one is the below the earth. Okay, so the center of the earth the value of g is 0, above the earth. Okay, that means the higher altitude the value of g will be decreased, and also the below the earth. Okay, that is the sea level, the value of g is decreased. Okay, in these two cases. Okay, so these two cases will be discussed briefly in your higher classes. Okay, that is 11th and 12th classes. Okay students, so our next topic is what means mass and weight. Okay, first we are going to learn about the mass. Okay, already we know that the mass is a basic property of your body. Okay, so mass is a basic property of your body or object. Okay, the mass is defined as the quantity of matter contained in your body. Okay, if we take on any object or body means how much amount of quantity it will be taken. Okay, so that is called as the mass of the body. Okay, so then the SI unit of mass is kilogram. Okay, already we know that. Then weight. Okay, so weight is the gravitational force that is exerted on your body due to the gravity. Okay, so weight is the gravitational force that is experienced by the body or gravity. Okay, so the weight is denoted as a capital W, that is related to the gravitational force. Okay, so already we know that W is equal to m into a. Okay, this is from the Newton's second law of motion. Okay, F is equal to m into a. Okay, here the force is related to the weight means we can put instead of F as W, and mass remains the same, and the acceleration A is replaced by g, because here the acceleration is the gravity acceleration. Okay, so we can get the equation as W is equal to m into g. Okay, already we know that the value of small g, that is acceleration due to gravity, is 9.8 meters second power minus 2. Then the weight is a vector quantity. Okay, so it has both magnitude and as well as the direction. Okay, but mass is a scalar quantity. Okay, the SI unit of weight is Newton, because it is related to the force means the SI unit of weight is Newton. Okay, and the weight is varied from place to place. Okay, it's not a constant value or fixed one. Okay, because it depends on the value of small g. Okay, that is acceleration due to gravity. Weight is depends on small g means it will be varied from place to place. Okay, weight of the body is more at the polar region. Okay, in the case of your polar region the weight of the body or any object is more, that means high. Okay, whereas in the case of a equatorial region, okay, in the case of a equatorial region the weight of the body or any object is less. Okay, then next one is the acceleration due to gravity on the surface of the earth is, we know g is equal to 9.8 meter second power minus 2. Okay, but in the case of the moon, okay, but in the case of the surface of the moon it will be changed. Okay, so that we have g is equal to 1.625 into 1.625 meters second power minus 2. Okay, so this is in the case of the earth and this is in the case of the moon. Okay, next we have to consider one person. Okay, one boy, he has a mass m is equal to 60 kg. Okay, his mass is 60 kg. Okay, if we calculate the weight of the person in both cases. Okay, so first case is if we calculate the weight of the person in the case of a earth. Second is if we calculate the weight of the person in the case of a moon. Okay, so first if he is stand on the earth means, okay, stands on the earth means the weight of the person is if we know the formula, W is equal to M is equal to G. Okay, so M is 60 kg and G is 9.8 meters second power minus 2 in the case of the earth. Okay, so that the weight of the person is 588 Newton. Okay, this is in the case of the earth. If we take the case of the moon, M is same but G is changed, that is 1.625 meters second power minus 2. Okay, so the weight of the person is W is equal to 97.5 Newton. Okay, because here the G is changed. Okay, so in both cases the mass is remains same anywhere or everywhere. Okay, in both cases the mass is same but the value of acceleration due to gravity is different. Okay, in both cases, first case in the earth and second case in the moon. Okay, so from this we can say that the mass is remains anywhere. Okay, thank you students.